Managerial Accounting Example 5B. Excuse me. Alright, so in our last video I talked a lot about variances, but we didn't actually calculate anything. So let's go ahead and calculate the variances. What we're asked for is the direct labor, direct labor quantity variances and rate variances. So if you think about the conversation we had last time, if we think about, we'll do direct labor first here. If you think about direct labor, we could have either paid more than $12 an hour, or we could have used more than 15 minutes per cookie. In order to answer the question of why the actual was 172, we kind of need to know how many direct labor hours we used and what the total price of those was, that kind of thing. Now you're going to have to be given more data than is in your flex budget. And if you look at the example, we're told here that further investigation revealed that the company used 13,760 direct labor hours to make the 43,000 units. So now we know how many labor hours were used. We also know the total labor cost, so it's not that hard to back into what the labor rate per hour was. In order to understand that difference, though, we need to understand how much of the difference of 43 relates to the number of labor hours and how much relates to the price per labor hour. So the variance model that has been worked up is one that counts both of those things sort of separately. We split out the effect of the hourly rate from the effect of the number of hours. And so what we do in one column over here, we put our flex budget, which is based on our standards. So whatever we expected to have happen, that's what's going to go in this column over here. Probably don't need two columns there. And then, we're going to leave some space. And over here, we're going to put our actual results. Now, how did we get our flex budget? If our flex budget, if you go back here, our flex budget is $129,000. How did we get that? Well, if you think about what we're doing, we're thinking about the price of labor, $12 an hour, and we're thinking about the quantity of labor, 25 or 0.25 hours per cookie. So what we really want to do is state our $129,000, not actually how we have it before in dollars per cookie, but in dollars per hour times the number of hours. So what I'm going to do is I'm going to first put the price, and the price is going to be $12 per hour. And then we want to think about the quantity. How many hours should we have used? And if you want to think about the number of hours, we should have used 0.25 hours per cookie times 43,000 cookies. So our budgeted or standard quantity of hours should be 10,750 hours. This right here, this concept here, the number of hours we should have used to make the actual output, is called the SQ, the standard quantity. And it's probably the most difficult concept in all of the variances. It's easy for students to confuse this with different things, but really we want to know what SQ is, the standard quantity or budgeted quantity of an input that should have been used to make the actual output. That's what SQ stands for. It's really, really important concept. You've got to get that. We put those two things together. $12 an hour times 10,750 hours, $129,000. Now our actual results. We know that our actual results are $172,000 in total. We know from the given data that we used 13,760 hours, and so we can back into, by dividing, we can back into the actual rate per hour. So here's our actual price, here's our actual quantity of hours, and here's our actual cost. So this so far hasn't told us much new. We knew we had to make $12 an hour. We knew we were going to use 10,750 hours, or we could have calculated it. And we knew our budgeted cost should have been $129 for the 43,000 units. We knew our total cost was $172, and we knew from our given data that we used 13,760 hours. So the only slightly new piece of data is the actual price per hour. But we can do something different here, and we're going to put a new column in the middle. And what we want to do to hold constant one of these things at a time is we want to put, we want to take one item from this side and one item from this side and put them together. And first I'll show what we do, and then I'll tell you why we do it. This difference of 129 versus 172 depends both on the increase in price per hour and the increase in number of hours. What we want to do to figure out how much of the increase relates to the price per hour, which is this difference here, and how much relates to the number of hours, which is that difference there, we need to hold one constant at a time and only let one thing change at a time. So what we do is we have this column in the middle that's sort of a hybrid. It takes the standard price and multiplies it by the actual quantity. So there's not a real good title for this, so I call it SPAC. And it's just dumb enough you'll remember it, and it tells you what to do. You put the standard price and the actual quantity, because you could easily say, well, why don't I put the actual price and the standard quantity? And the math would work, but the concepts don't work out. So that's our SPAC column. That's our standard price of the actual quantity of hours. Why do we do that? We do that because, as we talked about before, the production manager who's in charge of using people's time efficiently may not have any control over and may not even know how much each individual employee makes. Production manager probably knows about what each different job category makes, but somebody may have gotten a slight raise over somebody else. Someone might have been there more years. Someone might have a particular certification or quality of work that they've been able to get a raise over a certain time. And the production manager shouldn't really necessarily be in charge of thinking about every individual person's individual wage. The production manager should be trying to use the mix of employees given a sort of standard or expected wage rate. And so when the production manager is trying to do work, we shouldn't really expect that person to be accountable for the actual price so much as the standard price. So to protect the production manager from differences in actual prices that really aren't that job's responsibility, we're going to hold the production manager accountable for the number of hours at the standard price. So by using the SPAC column, we now know that the standard cost of the 13,760 hours is $165,120. And so the difference between the flex budget that should have been and the standard price of those hours is $36,120. Is that favorable or unfavorable? Well, we used more hours than we should have. It's going to cost the company more money. We're doing the accounting from the company standpoint, not the employee standpoint. So the company's going to cost more money, or company's going to spend more money. And so it's an unfavorable variance. Now, why was this variance? Why did it occur? Is it because the price was wrong? No, it's because the quantity of hours was wrong. So we're going to call that our quantity variance. It's often called, when we're talking about direct labor, the efficiency variance. Same thing. Quantity of hours used or the efficiency of the use of the input. 36,120. Over here, the variance relates simply to the price. The hours are the same, so the only reason that 162 is different from 172, or 165 is different from 172, is the price. So we can do the same thing here. The absolute value of the difference here is 68.80. Is this favorable or unfavorable? From the company standpoint, it's unfavorable. We paid too much. This is our price variance. In the context of direct labor, it's often called a rate variance, but it's really based on the price of the input. So these are our two variances for direct labor. The quantity or efficiency variance, 36,120 unfavorable, and the price or rate variance, 68.80. And together, these two things, if you put them together, you get the 43,000. You can see way down here, and that's the $43,000 difference between 129 and 172.